are analyzing the function, rational functions again. So, once again, we need to be able to find all 7, 8 things here. 8 or 9 maybe, huh? So we need to type it in our calculator, first step. We want to graph it. So I typed it in there, and look at that. There is hardly anything there. I can't see anything. I'm going to zoom in a little bit. So I'm going to go to negative 0.4 maybe, and positive, oops, wrong way, negative 0.2 and positive 0.4. That's what I'm doing. And we'll count by 0.1s. That way the little tick marks are 1/10, 2/10, 3/10, 4/10, that kind of stuff. There we go. Oh, look, you can see a max. 1/10, 2/10, 3/10, 4/10, and then over here we might need to go to the left just a tiny bit to see if we can see what's going on there. So I'm going to make this go to the left. I'm just going to make the x value, the x minimum, smaller. So let's see. Oh yeah, there we go. Now it's easy to see that there's a minimum and a maximum. Alright, so what we notice here is there's not a vertical asymptote. The other one had vertical asymptotes. This one has a horizontal asymptote, but no vertical asymptote. So how do I know that? How do I find the vertical asymptote? Remember, to find the vertical asymptote, the rule is vertical asymptote, asymptote. What makes the denominator equal 0? Well, if I do x squared plus 5, go to my quadratic formula, what makes that work? And I say 1. Remember, there's 0, there's no middle term, and positive 5. I get imaginary answers. Imaginary answers, that's the square root of 5 and negative square root of 5i. I times radical 5 and negative I radical 5. That's what that is. Well, that doesn't, there's no X-intercepts then. There's no real X-intercepts. So what's going on? Well, there's none. No vertical asymptote, right? What about the horizontal asymptote? So the horizontal asymptote, there was a rule that deals with the horizontal asymptote, and that rule was you look at the degree. Remember, the degree is the highest exponent. The highest exponent in the numerator and the highest exponent in the denominator. So this is the degree of the denominator, this is the degree of the numerator, and if the degree of the bottom is bigger than the top, the exponent on bottom is bigger on the top, the horizontal asymptote is always 0. So that's what happened here. The horizontal asymptote is always 0. Now, it's not always the case that this exponent's bigger. So we'll have some tomorrow or the next day where these exponents are the same, and then we'll have others in a couple days where the top one is a bigger exponent than the bottom one. So we've got to be able to do that. Okay, so we know where the asymptote is. Asymptote's at 0. So we'll type that little guy right in there, bump, 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 like that. There we go. Now then, remember my picture looked like a big swirl here, up and down. So we need to know where is it crossing the x-axis and where is it crossing the y-axis, and what's the max and what's the min and that kind of stuff. So we've got our little graph looking like this. And it comes up, and then it goes up, and then it goes back down, and then goes like that. All right? So what's happening over here is on the left, it's really close to 0, but it's underneath. And then in the middle, it crosses. Remember, it's okay to cross the horizontal asymptote. You never cross a vertical asymptote, but it's okay if it's close to the center, it can cross the horizontal asymptote, and it does. And then this one comes down and gets really close to 0 on the right, but it's on top. So here it's on the bottom, here it's on the top. Where is the x-intercept? Well, to find the x-intercept, all you have to do is say what makes the top equal 0. When is the top equal 0? So x plus 1 equals 0. So subtract 1, that's easy, huh? X equals -1. Ah, the x-intercept is -1. Lo and behold, the x-intercept is in fact -1. Ta-da! What's the y-intercept? I don't know. Let's find out. The y-intercept happens whenever you plug in x equals 0. So if I put 0 on the top, I'll have 0 plus 1, that's 1. 0 squared is still 0 plus 5, that's 5. 1/5. The y-intercept is 1/5. That's 0.2 if you like decimals, right? So it's at 0.2. So that's what we did. There we go. That's the y-intercept. What's the min and the max? Alrighty. So remember, I changed my window so I could see the top little bump and the bottom little bump, right? So if you didn't see me do that, I have x going out to -9. Can you see that? I don't think there's any way. Yeah, let's go. Let's zoom in. So I have x going out to -9 on the left and positive 4.7, 5 on the right. And then the y minimum, I have -0.2, and the y maximum, positive 0.4. Right? So that's why my graph looks like this. If yours just looks like a straight line or not very much wiggle, that's because I zoomed in. You need to know how to use your calculator. You zoom in and zoom out. That's what you need. So I'm going to find the minimum first. So I'm going to go down to number 3. And then it says, what's the left side of this lowest point? So I'm thinking way over here is the left side. So I went out to 5. And so that's the left. And then I'm coming way over here. And I got to about 2. And I said, that's the right side. And then guess in the middle somewhere. So I'm going to guess it's 3. And where is it? 3.449. Let's move that. 3.449, comma. And this is negative. I need more room. Let's do that again. We'll start with this one. -145 and then -3.449. So that's the minimum, right? The minimum happens right there. What's the maximum? Alrighty. So I got to go second trace, go down to number 4. What's the maximum? I'm thinking the left bound will be 0, so that's right there. And then the right bound could be, I don't know, 3 maybe. There we go. And then where is it? I'm going to guess at 2. And it's actually 1. So this is 0.345 and 1.449. Okay, so that's the max and the min. Right? So the next thing we wanted to know was where is it increasing? Increasing. So you need to be able to say, I know that if I'm driving my car, I'm going downhill until I get to that spot. And then I'm going uphill until I get to that spot. And then I'm going to go downhill the rest of my life, right? So all I care about is increasing. So I start increasing at the x value. Remember, this is the x value that make the y value increase. That's what we're asking, right? What's the interval? It starts at -0.5 3.449 and goes to positive 1449. So that's when it's going uphill. That's the only time it's going uphill. At -2, it's going uphill. At -1, it's going uphill. At 0, it's going uphill. At 1, it's going uphill. And then at 1.449, it stops going uphill. And then after that, at 2, it's going downhill. At 3, it's going downhill. It's going downhill the rest of its life, right? So here it goes downhill from -infinity to that point right there. And then uphill to that point. And then downhill again. Okay. All we care about is increasing, so that's all we're writing. And then what's the domain? Well, look, there's no intercept. There's no hole in the graph. So the domain is all real numbers. Ha ha. Everything, all real numbers. Did you see me do that? I hate myself. Okay, so I found the max and the min. And then I found the increasing. That's what we're dealing with. Then the domain, all real numbers. Look at that. Yeah. Okay. And then range. Finally, range. So, what's the lowest point on this graph? Well, the lowest point is negative 145. What's the highest point? Positive 345. What is the range? The lowest y value that this ever gets is here, and the highest y value that this ever gets. All the rest of them are close to 0, right? This goes all the way close to 0. This goes close to 0. None of the other numbers are any bigger than that. That's the range. So we found the horizontal. We found the vertical asymptote. There's not any. What makes the bottom equal 0? The rule says that if the denominator has a bigger exponent than the numerator, the horizontal asymptote is always 0. We did that. We found the X-intercept. What makes the top equal 0? We found the Y-intercept. Plug 0 in and see what answer comes out. We found the minimum. We found the maximum. We found where is it increasing. The X numbers, these two X numbers, where it's increasing. And then these two Y numbers are the range. Right? That's why we had to find all this stuff before we did domain and range. That's it. Booyah. We're done.